Okay, welcome to Lab 4 for data journalism. The purpose of this lab is we're going to continue learning a journalistic approach to data analysis in R. We're going to continue doing everything we did in our previous lab, which was we are writing R code for data analysis and exploration inside of RStudio. Using both R projects and R markdown files. We're going to load and make sense of and analyze data in the Tidyverse framework of packages. We're going to do what we did last time, which is select certain columns, sort, and filter. We're also, again, working with data on opioid shipments in the US from the ARCOS database released by the Washington Post from the DEA. We're also going to think about ways to use documentation and additional reporting to check our analysis, make sure it's not wrong, find interesting questions to ask. Today we're going to learn to do some very light data cleaning. There'll be some more substantial data cleaning later in the semester. We're going to learn to create some new columns in our data set based on information from other columns, a very common task. And we're also going to learn how to summarize raw data by grouping and calculating summary statistics, minimum and maximum values, medians, means. We're basically going to be using R to create a pivot table-like thing, which is something we did in Google Sheets. We're also going to learn how to integrate it later on with GitHub. That's how you're going to turn in your homework going forward. So we'll talk about that probably in a separate video after we finish this one. Okay, so again, this should seem somewhat similar to you now. The document here is set up for you to follow along and run code that I have written. You're going to listen to me explain it. It's important to listen to the video because I sometimes offer additional contextual information that goes beyond what's written inside of the R Markdown document. So mostly you'll be running what I wrote, but sometimes you'll see the word task that indicates that you need to do something, and usually that means that you're going to modify the file by creating a code block, writing some custom code. So when you're all finished, you're going to save your R Markdown file and knit it as you were instructed in the last lab. If you need some additional information on how to figure that out, you can Google it or look at the previous lab. Instead of uploading your R Markdown file and HTML file directly to Elms, there's going to be a process that will be explained in an additional video where you're going to upload this to a website called GitHub, and then you're going to post the links to that so that I can take a look. If you need help, in the document you'll see there are a bunch of resources, including a great online textbook, R for Data Science. There are cheat sheets up at the RStudio website, documentation guides to some of the Tidyverse packages, Reader and Tidyr and dplyr. And then I'm also posting a link, and I'll post this again, but for GitHub Desktop. And you can always reach out to me. Okay, so far you should have done the following things. Downloaded the zip file from the course GitHub repo and opened it on your desktop. It should contain this document here, lab04.r markdown. Over in the browser we can see it. And a data folder with one TSV. That's ARCOS WV Mingo 54059 itemized.tsv. So you've opened this in RStudio. You have renamed this your lab04 underscore your first name, your last name .r markdown. This will help me kind of keep track of it later on. You're also going to create a new R project inside of this folder. We're going to do this now. This will set the working directory to this location, which when we read in data is important, so the computer knows where to look for it. If for some reason you cannot create R projects because, as some of you told me, your computers are just crashing when that happens, up here you can go to More and just select this button, Set as Working Directory. That'll set the working directory here so that data loading will be easy. For everybody else, go up to the File menu in R, and I actually can't see it because it's slightly off the screen, but you're going to File, selecting new project, which you should be able to see in the upper corner. And just go ahead and save it in case you may need to change it. You're going to associate it with an existing directory. So existing directory, you're going to browse. You're going to find the location of the folder, probably somewhere on your desktop. In my case, it's in a different spot. And just go ahead and create this R project. So we're going to create it. And the file closed, so I'm just going to reopen it there. Okay, so just going to scroll back down to where we are. Today we're going to load at the top of our document, right? A thing we always want to do is load our packages. Good practice to be in. We're going to load the tidyverse. If you are doing this on a computer which you have already installed, you're not going to need to install it again. If you're working on a new machine, you're going to have to use install.packages, something we learned in the last video. Welcome to go look at that. To install the tidyverse. Otherwise, you're just going to need to load it. We're also going to use a new package today called Janitor. I can command click here to open links in these docs. This is a really cool package that SFERC released. And it's got a cool little sticker of a janitor. It's basically all about data cleaning. It makes a lot of data cleaning tasks sort of easy, and we're going to be using it for one very specific thing today. So this is the second package we've worked with. So the first time that you've done this, you're going to need to uncomment this and hit the play button, and it will install it. And I already had it installed, but if you haven't, just go ahead and run that. And then we need to load both the tidyverse and Janitor after it's been installed. So library, tidyverse, and library, Janitor. So if you want to copy this from a previous document, that's fine, but go ahead and write that in here and run this code block. Okay, so we're loading the data. By now in class we've worked with two counties, Logan County, West Virginia, shipments of opioid pills to Logan County, West Virginia, and Mingo County, West Virginia. Today we're working with Mingo as we go through the document. The reason I'm doing this, by the way, is so that we can you can really start to develop an understanding of the state of affairs in some specific counties, so that we can really focus on learning kind of the process of analysis here. We'll later move on to other parts of the country, I promise. Okay, so we're working with Mingo. The handbook is here, and as a reminder, this was data obtained by the Washington Post and the Charleston Gazette Mail after a lengthy legal battle over getting access to this, and it was released by the Post. Okay. First thing is we're going to load it in and store it as an object called Mingo. And I'm going to give you a second just to see if you can write it on your own. Remember, the function is read TSV, and we need to navigate the path to the folder. So remember, we're storing it as an object called Mingo, and we are reading it in. So you will do this if you continue to work in data journalism or use data journalism in your reporting. You're going to get used to writing this, so might as well memorize it now. But here it is. So Mingo read _ TSV. There's the path to the data. It's in a folder. Oops. It's in a folder called data from our the file we're working in, and we can just load it in here. Okay, and remember, it pops up in the environment window. It's got 37,000 rows and 42 variables or observations and columns. Just as we did before, let's just use a couple functions to get a sense of the data. So we can use glimpse, which will tell us some basic things about what the columns are, some sample data from each of the columns, how they've been written in and stored. So double is a kind of number, CHR is a text string. Just to get a sense. I know you've worked with these counties and this data set a lot, but it's a good habit to be in. We can also use summary, if you recall. So summary gives us, and I got an error there because I hadn't put the name of the data frame in there. So summary Mingo. It also gives us a sense of the columns. Doesn't give us sample data. For numeric columns, it does. The one kind of nice thing it does is it gives us like some summary stats, so minimum and max for the dosage unit, which is the number of pills, median values, mean values, all pretty useful. And then of course we can view. I'm actually not going to write that into a code block here. Probably the easiest way to view would just be double click on the data itself, link over here, and you can get a sense of it. And just remember, we can also like sort here, and we can also use filters here. As we kind of mess with the data. Remember, none of the stuff you do here is preserved, so it's a much better idea to really like write scripts to keep everything down, to document it. Okay, so you've got a sense of it now. So we're gonna go more in depth again in data cleaning as the semester goes on. And just a reminder, it's not the fun part, but it is critical. And if we fail to do it on messy data sets, it can make our analysis really hard, or even worse, it can lead to inaccurate results. So the Janitor package that I showed you before is awesome. It does a bunch of things. You'll find, especially when you get like weird spreadsheets from public records requests, people have like put in blank rows and not labeled column headers, and it does a lot of nice things to clean that up. One of my favorite things, and that's useful for this data set, which actually came across in really good shape from the post. My sense is they probably did a lot of data cleaning to it. One thing it's great at is it cleans up, Janitor will clean up column names. So if you notice in our Mingo, right, we have a combination of uppercase and lowercase names, or what's called like capitalization case. Everything is separated with underscores. We don't have any spaces in the column names. That can make things really tricky when that happens. But there is a nice way that we can clean that up. And there's a thing called the clean names function. We're gonna use that to make everything lowercase. So what I'm doing here with this function is there's a function in Janitor called clean names. And then it's called, the thing we want to clean is the data frame called Mingo. And notice I'm storing it as Mingo. So what I'm doing is I'm overwriting here. I'm basically saying take the original copy and load it up. This may seem like it runs counter to what we talked about in Google Sheets, where we always preserved an original copy of the data. It's sort of different here. Remember, in this folder is the original copy of our data that if we ever screw something up, we can just go back to the top and run everything again. So not the end of the world to overwrite here. Some people will, every time they do something new to it, will make a new object. I find that tends to clog memory. Okay, so we cleaned it up. And now let's just take a look here. Let's do another glimpse function on Mingo and print it out. And if you compare it to what's above, you'll notice everything is all lowercase now. It's sort of easier. You don't have to remember, was this column uppercase or lowercase as we go through. So one little bit of data cleaning. Okay, so today we're going to learn a lot about how to create new columns based on values in other columns. As we saw when we worked through Google Sheets, we do this a lot in the course of our analysis. In the tidyverse, probably the most common function we use for making this easy is a thing called mutate. And you can read more about it up on I just clicked a link there to the dplyr reference page. And it's all about creating or transforming variables. There's a similar thing called transmute that adds kind of new variables and drops existing ones versus mutate, like you add a new variable and you keep the old ones. Transmute is similar but slightly different. You can read sort of how that works there. Always good to know where the documentation is, how to use it, because we're not going fully into depth about everything you can do with dplyr. Okay, so probably the simplest example I can think of using mutate is we're basically going to take an existing column and we're going to make a copy of it with a different name. This is not something we do often, but it is going to help us understand at a fundamental level how mutate works. And before I go any further, I just want to make one other note here too. In all of my examples below, because I'm just showing you how to use some of these functions, what I'm doing is I'm taking the original data set and I'm doing something to it, and I'm storing the results as sort of a working object. And I like doing this, especially when I'm just doing, sort of a lot of messy exploratory analysis. Instead of storing, say, Mingo working down here, right? So I've got an object I'm creating called Mingo working, and I'm storing the results of this thing I'm doing to the Mingo data set. If I overwrite it here and I make some mistake, if I just said like overwrite Mingo, store what I'm doing to this as Mingo, it would overwrite this, right? And then if I made some mistake, I'd actually have to go all the way back to the start and like load up, I'd have to load up the data set again. And I really don't want to do that, especially with big data sets. It takes time and it's just annoying to scroll back up. So a thing I like to do is just do Mingo working as a working file. Another thing to point out is that I really only, in my sort of real life as a data journalist, I generally only store a query as a new object if it's too big to print out nicely in the code block. I like to write things that just can print out below here and I don't need to pop out into an additional window. Or if I want to create a slice of the data that I'd like to incorporate into future analysis. Like I know I'm going to do a bunch of analysis looking at transactions involving just one company. I might create a slice of the data that only contains transactions to those companies and just use that. So I don't need to like keep adding a filter function to every one of my things, new queries in the future. Below, when we get to summary table, pivot tables, essentially, I'm going to stop storing it as a separate object and just print it out below. But right now we're doing things that are creating slices of the data that are just too big to fully print out here, so we need to be able to view them. And to do that, it's helpful to store them as a new object up here. Okay, so something to remember about our data set is that it contains a record of a shipment of opioids, hydrocodone and oxycodone, from a manufacturer to a distributor to a pharmacy, and it's got a lot of information about each entity and information about the quantity and type of opioid ships. Unfortunately, the columns in our data set don't really refer, the column names, and this is something we see a lot, don't actually refer to the words we're calling them by, manufacturers and distributors and pharmacies. Information about distributors is actually in a column, in a set of columns tagged reporter. Information about pharmacies are labeled buyer. And information about the manufacturer is in the labeler or company column. So just to look at that, here's all the reporter columns. These really all represent distributors in the slice of the data set we're working with. Buyers, in this case, for the most part, they represent retail pharmacies, but they also represent some like practitioners. This is a vet, I think. And then the manufacturers are all the way over here under combined labeler name or revised company name. So just something to think about here. Okay, so something we might want to do is actually go in and when we start working on our analysis, like rename the columns so that we know like what we're looking at. And here's a code block below that might offer an example of how to do that using the mutate function. So here's what this column says. It says, create an object called Mingo working, take the Mingo data set and mutate, and essentially what we're saying is we're going to create a new column. We're going to create a new column called distributor DEA number, and the information that we're going to put in the distributor DEA number is the information that is currently stored in our data set in a column called a reporter DEA number. So this is a unique identifier for each distributor. And what we're saying is we're going to create a new column with a different name, take this information and put it in there. So let's go ahead and run that. You'll notice I got Mingo working up here. Same number of rows, but now I have one more column, 43 columns. I click on it and scroll to the right. Here's the reported DEA number. Here's the distributor DEA number. Same thing, just under a different heading. And I put it at the end, which is kind of annoying, but I want to point out that just like we could combine select and filter and order by statements in the same clause with these pipes, right? Like I'm taking the Mingo data frame and I'm doing a bunch of steps to it. We can also combine things we already learned like select with mutate. So in this case, what I'm saying is take Mingo working. This is this same object. We already created it up here, so now we're just overwriting it. Take the Mingo data frame and mutate it to create this new column. Then at the very front of our the data frame, we're going to put this new column we created and then put all the other old columns after it. So when I run that and then double click to open it here, now we've got the distributor DEA number. That's the newly renamed column we created. And we have this reporter DEA number. This is our old thing. Notice they're exactly the same. If we then wanted to just remove that, essentially letting our newly created column take its place, we could do that. So this is the same bit of code as above. Just added one more select statement down here in which I'm saying remove the original column, reporter DEA number. So now we have distributor DEA, so now we have the distributor DEA number, that reporter DEA number is missing, and we have all our old columns. Okay, so it really was just a sort of a lesson to teach you about mutate. It's a pretty complicated way of going about renaming a column. There's actually an easier way to do that using a very helpful function from dplyr called rename, which is sort of a cousin to the select column. So you'll notice it sort of looks like the mutate thing we did, but it's all the same code we had above, just in a slightly shorter fashion. So I'm just saying take the original Mingo data frame, rename it, rename the column distributor reporter DEA number as distributor DEA number. And when I open it, there it is right there. Okay, just another use case where mutate might help. Let's take a look at the fields describing the location of the pharmacies under columns that are tagged as buyer. Notice that they're broken into multiple parts. So I'm just going to go ahead and pop open the original data frame here. Scroll to the right. So we've got, it's doing that thing where when you load up a big data set in R, sometimes the columns and the values in the columns don't align, the column headers. So let me just reopen it and then we'll scroll to the right here. Okay, so we've got this buyer address 1, buyer address 2, buyer city, buyer state, buyer zip. Those are all broken out into separate things. It might be useful to put all these things together to have it in one address field. This might be especially true if we wanted to like make a map with this information and geolocate it. This process that we're going to do, taking column information from multiple columns and putting it together, is often called concatenation. Actually, in Google Sheets, the function is, I think it's concat, it might be concatenate. Here, there's kind of a handy one. There's actually a bunch of different ways we can do this. The Tidyverse has one called Unite, which is part of the tidyr package in the Tidyverse. And you can see the documentation here, which will tell you a little bit more how to do it. I just want to walk through how we might do that. This is actually a case where we're not going to use mutate at first. We're going to use this unite function, but later on towards the end of the example, we'll actually end up using mutate. So I've got some code here, which again is taking the Mingo data frame and doing a bunch of stuff to it, storing it as this Mingo working. We're going to keep using this throughout. So I'm going to select all of the columns that contain buyer. So if I were to just run that piece of it, what you would see is here are all of the counties, all of the columns with buyer in the name. We learned that contains thing in our last lab. And then I'm adding something called unite. And so the first argument or thing that unite gets is the name of this new column we're creating. So I want to create something called buyer address complete. And then here are the columns I'm sticking into it. So I'm going to press play, can pop it open. Here is buyer address complete. Now you'll notice that it actually went through and got rid of all the other info. Like it didn't preserve the 210 Logan Street here, right? Or it didn't preserve the city or the state separately. It just put it all together. Also notice it's separating it with underscores, which is a little bit weird. So the first thing is we may actually like think it's really useful and want to keep doing analysis on some of the individual columns, like state, for example, of the pharmacy or the city, something like that. So we can actually add another argument to our function. In this case, it's remove equals f, which stands for false. And by doing that, what it does is it creates our new column, right? Buyer address complete, but it keeps all the old stuff, which is maybe a better thing for us. Sometimes you want it, sometimes you don't. And again, as I said, it's putting underscores between each column, which, I don't know about you, but I've never in my life seen an address that looks like that. So we can actually use a different character to separate it. In this case, we're saying we're adding another argument, sep, and we're saying add a space between each column. So there's double quotes, and then there's a space there. If I want to add a comma between each one, I can put a comma in, but let's go ahead and put a space. And let's take a look now. And now we have some space between each thing. And actually, hold on one second. Okay, let's run that actually again. And now we have spaces between each one. I also left out this buyer address too because it contains a lot of null values, but if we were really doing some serious data cleaning, we would want to find a way to correct for that. Okay, this still isn't like ideal though. This doesn't really look like you'd expect an address to look, right? Normally we'd expect like maybe a comma after Logan Street, comma after the Williamson, between Williamson and West Virginia, between the city and the state. Unfortunately, like sometimes when we use pre-built functions like unite from tidyr, we're limited on what we can do. And we have to sort of fall back to other functions that maybe gives us more flexibility, but is like slightly more complicated. So in this case, if we want to format our address so that it actually like is a complete address, then a thing we want to do is start using mutate and use another function that is from base R called paste zero. And paste zero is another way of concatenating or uniting. So I just want to take a look at the output of this code, and then we'll talk about what it does. But again, we're taking the Mingo data frame, we're doing something to it, and storing it as an object called Mingo working. And the thing that we're doing to it is we're saying create a new column called buyer address complete, and set the thing that's in that column equal to pasting the following things together. Okay, So let's run that and take a look. And it's going to stick it all the way at the end. Okay, this isn't much better actually, because instead of having spaces, now it's all like running together. And we need to fix that. So what we can do is, instead of just having the names of columns in here, we can additionally start adding other kinds of characters. So between the buyer address and the buyer city, I'm going to put a space. Between the buyer city and the buyer state, I'm going to put a comma and a space. Between the buyer state and the buyer zip, I'm going to put a space. Okay. And now we scroll all the way to the end. This looks like a kind of cleaner address. Okay, good. So here is what I want you to do now. I want you to create a code block below, and I want you to create a new column that builds as complete an address as possible out of the information about location for the distributors in this data. So just remember what we have called the distributors data, and maybe work on modifying this function to do that. And go ahead and pause while you do that if you like. Okay, so we can also, another sort of common thing we can do with using mutate to create a newly created column based on the value in another column is to classify something differently depending on the value in one column. Let me try saying that one more time. In Google Sheets, we used if functions to take our opioid data and look at, say, the number of pills that were shipped in a given shipment, and to classify it in a new column as a large shipment or a small shipment based on the number of pills in that shipment. So again, in Google Sheets, we did this with if functions. In R, there's a similar function in the tidyverse called if-else, if_else. And the code below basically does this. It creates a new column called pills category, and it says if-else. So if the number of pills in the dosage units category is more than 10,000, call it a large shipment in this new column we're creating. If it's not a large shipment, if it's less than 10,000 or equal to 10,000, less than or equal to 10,000, call it not a large shipment. So let's take a look at that. And it cannot find dosage units. Because it's dosage unit. So this is a reminder of an error in R. Very common when you're working. And let's take a look. Okay, so we have this new column called not large shipment or large shipment. When I sort it, you can see some are classified as large, some are classified as small. Okay, so let's suppose we wanted to create 3 categories, like small, medium, or large. If it's bigger than 10K, we'll call it large. If it's bigger than 5K but less than 10K, we'll call it medium. Otherwise, we'll call it small. So just like in Google Sheets, if you remember, we could do what's called a nested if function. So what we're saying here again is create a new category, a column called pills category. Okay, so just to back up, we're basically saying if you if we have total number of pills in a shipment of greater than 10,000, call it large. If it's greater than 5 but less than 10, call it medium. Otherwise, call it small. I'm creating a nested if statement. So first we're saying here, it was basically binary. It's either small or large. Here we're saying if it's bigger than 10, make it large. If not, go to this next if-else statement. And in that if-else statement, if it's greater than 5, call it medium. Otherwise, call it small. It's a little clunky, and when you start getting to the point where you're writing like trying to create 5 categories or, but more than that. These nested if statements can get out of control. You never can remember how many parentheses you have to close. So there's a better thing for that in the tidyverse called case when, which I highly recommend looking at the documentation about. It's a general vectorized if, and there's lots of examples for how you can use it in more complicated ways than we're looking at here. But it's sort of like an if-else statement. It's just structured a little bit differently. So here we're saying create a new column called pills category again, and when the dosage unit is bigger than 10K, then call it a large shipment. If it's greater than 5K, call it a medium shipment. Anything else, which is what we put true, small shipment. We're using tildes and some other stuff here. But it basically functions in exactly the same way. So you'll see this this multi-part column all the way over here. You turn on filters, you can see the large or the small or the medium. Okay. All right, so I want you to create a code block below, and I want you to use case when, or if you want, use if else, to create a new column called state distribution that looks at the distributor state column. If the distributor state is in West Virginia, where we're looking, then the new column you're creating should have a value in it that says in-state distribution. And if it's not in West Virginia, it should say out-of-state. So just to show you a little more precisely what I mean, here is the distributor state, right? So this distributor, H.D. Smith, is in Kentucky. This one's in Virginia. So if it's one of those values, then in the new column you're creating, it should say out-of-state distribution. But if it's West Virginia, then it should say in-state distribution. Okay, again, just to refresh, if the distributor state's in West Virginia, it should say in-state distribution, and if it's not in West Virginia, then it should say out of distribution in this new column that you've created called state distribution. Another way we can create new columns is through a process of summarization. This is like the R equivalent of creating pivot tables. That is to say, we're going to group like values in one column, or sometimes more columns, and then calculate some things based on those groupings. And this is a great way of synthesizing new knowledge and information from raw records. It's the kind of thing that I would say is among the most common tasks before data journalists. There are a bunch of others, but it's super common. I want to show you probably the most simple example. In this, we're going to group by the name of each pharmacy in our database, and we're going to count the total number of shipments to each one. And remember, one record represents one shipment in this database. Just a note about what we're doing below. Above, we were, in almost all cases, storing what we were doing as a new object called Mingo working, and just continuing to overwrite that. The reason for that, again, was that we weren't really aggregating the data, and the results we were producing were still for the most part 37,000 records long, which were way too long to store in the tables that appear below the code blocks that we're making inside of this R Markdown file. Now that we're aggregating, we're actually going to be creating much smaller tables that are output. So it's appropriate in these cases to just store this information as a code block, as a table below here, instead of saving it as a new object. So when I run this, it's just going to output here. It only has 14 rows. And I can page through those pretty easily, so totally fine now. As long as it's under 1,000, it can be a manageable way to look at the data, but up to you. Okay, so what I did in this case was I took the original Mingo data set. I grouped by the buyer name, which for the most part are pharmacies, but there's some vets and other things in here. And then I'm inside of this summarize function is where I'm calculating some aggregated information. So what I'm doing here is I'm saying create a new column, so group by buyer name, create a new column called shipments, and then in that information, the function n just takes essentially the number of rows or the number of records. So there are 2,491 records in which Adkins Pharmacy Inc. is the buyer. And then I output it there. So this is essentially a pivot table. You've made a very simple pivot table here. We can, just like with other things, we can combine our grouping and summarizing statements with other types of functions using the pipes. So in this case, I'm just reproducing that same thing I just created above, but I'm just sorting it by the number of shipments from highest to lowest. So we get the same table above here, but now we have Hurley Drug Company with 11K shipments as our highest, all the way down to David Nielsen, who's probably some kind of medical provider at the other end. This particular company, pharmacy had or this particular name of a company had the highest number of shipments. Could be a good place to jump off for further reporting. Who knows what's going on there? That's what you would need to figure out. Okay. We can also use filters too. So in this case, again, I'm building a pivot table in which I'm grouping by the name of the buyer, the pharmacy, in most cases. And I only want to look at pharmacies that got the largest number of shipments over 1,000. So in our table, we had above, we had 4, 5, 6 under 1,000. So after I produce the summary table, I can filter it to only get the biggest shipments. So again, I am grouping by the name of a buyer, creating a summary column called shipments that has a function inside of it saying n, so the number of rows essentially, for each pharmacy. I'm sorting it from highest to lowest, and then I'm also filtering it to only get the big ones. So it cuts off at 1,045. Just a note too, you can also filter before you get to your summarize statement. So we have two kinds of opioids represented in the data, hydrocodone and oxycodone. In this case, what I'm doing is I only want to look at hydrocodone shipments. I don't want to look at oxycodone shipments. There may be something sources told you about some material difference between those two that could be useful. So when I do that, what I'm doing is, this is the same code as above, right, in which I'm grouping by the buyer name. I'm counting, creating a column with a count of the number of shipments. I'm sorting. I only want to look at big shipments. But at the top, I've added this new line in which I'm filtering only for hydrocodone. And look, my total number of shipments are different, right? Instead of 11,000 to the Hurley Drug Company, I've got 9,000. So just keep in mind, you're going to get different results depending on whether you filter before or after. We can also do a lot more than count. There are all kinds of summary statistics that I think you'll find useful. In this case, this is my original sort of chunk of code above, right? In which I'm taking the Mingo data set, I'm grouping by the name of the pharmacy, I'm calculating creating a new column called shipments in which I am counting the number of rows, right? Which gives me as a proxy for the number of shipments. Then, with a comma, still inside of the parenthesis for summarize here, I am creating a new one. So total pills. And what am I putting in total pills? What is the value that goes in there? Well, I'm putting the total for each pharmacy of the dosage unit column. And the dosage unit column is essentially a proxy for the number of pills. And then now when we get down here to my sort, instead of sorting by shipments as I did before, I'm sorting by total pills. And we see at the top here, so Hurley, which was the top for shipments, this Stroh-Snyder pharmacy actually had more pills than anybody else in the data, more than Hurley, 13 million. So again, we can add as many as we want. We can do one, we can do multiple. I just want to run through some additional summary stats. So in this case, same function as above. Now I've just added this average pills per shipment, and I've set that equal to the average or mean of dosage unit. So when I run that, it tells me how many pills, take the total, it's essentially taking the total number of pills and dividing by number of shipments. On average, Stroh-Snyder had 17,000 pills per shipment. These top three had much higher average pills per shipment than most of the other pharmacies. So hard to say what's going on there. Maybe good reason, maybe a not so good reason, but further reporting could help elucidate that. Just gonna add a couple things, right? So min and max, right, will give us the smallest number of pills in a single shipment each pharmacy. Max will give us the biggest. And we're getting pretty big here, so I got to scroll to the right. And we've got, so the top one on our list was Stroh-Snyder. Their small shipment was 30. Their biggest, there was a single shipment of 24,000. That's pretty interesting. What happened there? What date did that occur? All these things that you could follow up and look at. So there's a ton of other summary stats you can calculate. The summarize page gives you some information on this. So some advanced stats, some normal stats. The documentation is also useful. I love these cheat sheets. I use them all the time. On this page here, it's got a list of all of the different summarized things you can do. If you want to calculate the interquartile range or the standard deviation or the variance, which depending on your project can be really useful, you can do all that. So I'm throwing a task at you here, and the task is this. I want you to copy the last code block above, so make a copy of this code block, and I want you to add one additional line inside of your summarize function. So I want you to put right here, I want you to put a new function, or create a new column that calculates the median number of pills per shipment. And you can look at both those documents. You can probably find the function that will allow you to do that. Again, get used to the process of looking up how to do stuff. A very common thing is to have a sense that something is possible, and then try and find it in a place that will teach you how to do it. Got to get good at that process. Just as in pivot tables, you can also group by more than one row. So it's important to think about, right, when you're calculating totals. Can we actually say, do we feel confident about saying that a pharmacy, this truly represents one pharmacy and not, say, maybe multiple pharmacies under the same name? So a way to do that often is to group by more than one row. So in this case, same function as above, but now I'm grouping by buyer name and DEA number. And let's see what we get. Okay, so we're grouping by two things, right? And if either of these things are different, we're essentially going to see what looks like a repeat, right? So we've got this appellation Reg Healthcare Inc., DBA, which stands for Doing Business As, Matawan Clinic Pharmacy. And it's got two different DEA numbers, close to identical, AM and then the same number, BM and then the same number. We also have this Medicine Cabinet Pharmacy, which has FM 2252372 and then another one under a different one. So something we might ask ourselves in these situations is, and these are problems we would have to resolve before we could report something based on this information. Are these two different pharmacies? Is this a typo or an error that led to this? Do they represent different locations? Are they different companies? We really need to get into that. And one way we can start to do that is by adding more columns in our group by statement. So buyer name, buyer DEA number. Now I've got buyer city. I've got buyer city here. And when we run that, we can see, okay, these are both in Kermit. And these are both in Matawan. So not really much help there, not really shedding any additional light on it. Now let's also add in the address info. So same as above. I just added one more line to our group by statement. Okay, so now we're on to something here. Medicine Cabinet, it's got two different locations. So this could be two separate pharmacies. Maybe it's one that, because there's such a small number of shipments, maybe it used to be here and it moved here, or vice versa, and it got a new number. These are things you'd probably have to make some calls on and try and resolve. Appellation, this DBA Matawan Clinic Pharmacy has the same address in both cases. So there may be a good reason why they'd have a different DEA number in each location, or it's possible that this is an error, but it's something you'd want to probably dig in on a little bit about. And it's, if you're just dealing with one county, it's possible to do that kind of reporting before you publish something. Okay, and what I would say is, this is a very common type of error I see, in which people are like grouping on the same, like too few things and not realizing that they represent different entities. I generally find it's better to like start the other way. Group by a bunch of stuff and look for these kind of repetitions, and then slowly remove them as you feel confident about it, right? Like if these two things have the same buyer address and city and state and same DEA number, then you can feel confident they're the same thing. But you'll start to see errors like this pop up when you use that approach. Okay, so generally speaking, it's also possible to, not generally speaking, it is possible, just as in Google Sheets, to rank with one of several rank functions. So the function dense_rank gives us kind of the standard ranking we're thinking of. One note of caution, the default ordering for it, the way it ranks things, might seem backwards. At least to me, it feels intuitively backwards. So the code below takes the Mingo data frame, and it groups by buyer name. And then it calculates the number of shipments as a count, right, equals n. Then it creates a new column called shipments rank, in which it says dense rank the shipments column. See that? We are creating a new column called shipments rank, and we're ranking the output from this shipments column, which counted the number of records. And then we're sorting based on rank. So let's run that. Okay, so we have the Hurley Drug Company, with 11,138 shipments. It's ranked 14th for shipments. Seems backwards to me. I would usually say like the most is ranked the highest, but that's not the way Tidyverse does things. But it is possible to flip that order. So this code below is exactly the same as the code above, but instead of just putting shipments inside of our dense rank function, I've wrapped it with DESC. It's sort of similar to how we sort, right? And when I run that, now Hurley is the top ranked one. Pretty handy too. The Tidyverse also has a nice function for calculating percentage rank. So, there are 14 pharmacies in our data for this county. at least when sorting just by buyer name. What percent rank does is instead of ranking like 1 to 14, it takes that and converts it to like a 0 to 100 percentage scale. So you'll notice this is like pretty much exactly the same as above, but I've changed this to say percent rank. And actually the default ordering for this makes intuitive sense to me. So Hurley Drug Company, right, is 1, so it's a percentage scale from 0 to 1, or 0 to 100 behind the decimal place. Hurley, as a drug company, has is in the top 100%. Stroh-Snyder, top 90%. Tug Valley, top 84. Gilbert, top 76%. So if you basically wanted to say, which companies are in the top 75% of all companies, all buyers in the county ranked by shipments, you would say, these 4. We can also calculate percentage of total. This is something we did in Google Sheets, right? In this case, what we are looking to calculate is we're looking at the total number of pills sent to each pharmacy, and then trying to figure out what percentage of all pills sent to the county as a whole, the percentage for that pharmacy represents. So we can start by calculating the number of pills sent to each pharmacy. So Mingo, we're grouping by buyer name, right? We're summarizing, we're counting the number of Okay, sorry. So again, what we are doing here is we want to start by calculating the percentage. Start by calculating the total number of pills sent to all the county. We're going to create that in a new column. So we've got 2 things here. We are grouping by buyer name. We are adding up dosage unit, so all of the pills sent to each pharmacy are going to get its own column, so that goes here. And then we're going to create a new column where we add up everything in the column we just created. So I'm just going to run through that one more time. We're taking our Mingo data set, we're grouping by buyer name. We're creating a new column where we add the results, where we add up all of the pills and all of the shipments sent to each pharmacy. And then we create a new column where we are adding up all of these shipments to each pharmacy. And the total is 38,269,000 and some change. Okay, now we want to calculate the share for each pharmacy and sort it on that new column. So again, what I've done here is I have this same function from above, right? So in the same function above, we ended up here creating this particular row, or this particular column. Now we are going to calculate the percentage that the portion sent to each pharmacy represents of all pills in the county. So we're going to divide the pills sent to that pharmacy by the total number of pills, and then we're going to sort. Just one note here, there's an option inside of RStudio that you're probably going to want to turn on, and that is to turn off scientific notation, unless for some reason you're really comfortable looking at scientific notation. I'm not. It basically tries to take very small numbers and make them look a little more legible. I find it confusing. So I just run this command the first time you do it in RStudio. So you're just saying options, SciPen equals 999. That basically means turn it off. So when you run this, now we're getting this new column here, right? It's called pharmacy percent total pills. And this is a 0 to 1 scale, so 0.34. So 34% of all pills in the county went to the Stroh-Snyder pharmacy. It's a third, way more than anybody else after Hurley and Tug. We can also, this is just a little bit of cleanup. we can take the same column, same function we wrote above, and just make it look a little more like a percentage by just multiplying it by 100. Now we get 34.409. That's also like still a little unwieldy. Nobody ever needs that kind of precision to a decimal place. So we can actually wrap this entire thing inside of a round function. So round, so basically it's the same exact thing we had above, but I just put round and then the thing we did, and then comma 2, which is the number of places. And now it's rounded to 2 decimal places. It can be kind of tricky to get the number of parentheses right, but just go ahead and experiment with it. Okay, so we're going to end this exercise today with 3 tasks that are designed to replicate some journalistic data analysis. So the first task, the setup, is that your editor asks you to figure out which manufacturer to distributor to pharmacy pipeline was responsible for the largest number of pills being shipped to Mingo County, West Virginia, as a starting point, essentially, to focus your reporting on the opioid crisis. So this could help us pop out a trend that seems significant. So remember, every shipment is every row is one shipment from a manufacturer who makes the drugs to a distributor, to a pharmacy or pharmacy-like entity, with a number of pills and the type of pills that are being sent. So this is something you could look at. So I want you to write a code block below. Go ahead and create it right here that groups the manufacturer name, the distributor, and the pharmacy name, and calculates the number of pills for each grouping. So your table should have 4 rows. So a manufacturer name, distributor name, and a pharmacy name. And then the total number of pills. So go ahead and create a code block below. And I want you to leave a comment with the answer, what is the most significant combo? Your next task, after you do that, being a good data journalist, you should be operating on the principle that everyone is flawed, and you should be extra skeptical of everyone's work, especially your own. So you're trying to figure out whether you can really trust the answer you just got. And you should always operate from the assumption that you screwed something up. So what I'd like you to do is start scanning through the table that was produced by the code you output, and take a close look at the distributor column, and look at Cardinal Health. It appears 3 different times: Cardinal Health Inc., Cardinal Health 110 LLC. And I want you to ask yourself, is this the same company? And if so, what steps can I take in my code to figure out whether that's the case? Is this different locations? That sort of thing. And I want you to put your code that you write below here. And then your last task is operating from the presumption that based on the code you wrote, that these are indeed 3 different locations, not like an error in how the data was input. But being a very careful reporter, you don't want to make any assumptions. You want to figure out if they are indeed owned by the same company. So you call Cardinal Health, they won't talk to you, but being a really good reporter with some creative Googling, you find a document on their website, and the link is right here, that suggests at least 2 of the 3 are owned or were at one point owned by this same big company, Cardinal Health. And you call a DEA spokesperson. She confirmed for you on the record that all 3 are owned by Cardinal Health. So let's suppose, right, that you're interested in looking at this company-to-company pipeline, not like location-to-location pipeline. And so you really, really want to find out if you can, you really want to clean up your data so that you know you're treating these 3 entities as one company. Otherwise, they won't group correctly, right? As you'll see in your output, these 3 things appear as separate rows in our data when we try and summarize. So your mission is to think about how you might clean this data based on things we went through here today, so that you could replace all of these disparate values, Cardinal Health Inc., Cardinal Health 110, with one single name, Cardinal Health. I know you probably don't know how to do this. Maybe you have a vague idea that you can use a case when function. And to answer this question, to do this task, I actually don't need you to write any code. I just want you to think out and try and be able to describe in English what it is you think you might do to fix this. Would you create a new column? And if so, what would you put in it, and how might you do it? So one thing you could do is you could go into the original text file in a text editor and change everything, but trust me, that would not be good. There's a much better way to do it. So what I'm trying to get you to think about is how to break down a problem that you're having, have a sense that yes, it's possible I can do this thing, because that's true of pretty much every data analysis thing. There's always a way to do it, even if it's hard. And then be able to put it in terms that you can search the web for on your own or talk to an editor. Okay. Once you're finished that, you are going to save this R Markdown file. You're going to knit it to HTML to make sure it compiles correctly with the knit button. Remember, that's up here. You're going to, oh, it did compile. Excellent. You're going to save it as a document. And then in a separate video, I'm going to walk through how you upload it to GitHub. And I will have you, instead of uploading the files directly to Elms, you're going to provide a link to your GitHub repo in Elms. And this other video will explain what that means. Okay.